Like, this quiz is super doable. Just put in the effort and you guys can do well.
Yeah.
Okay, so, okay, also one thing to note. So if I tell you this is the reaction, right? What's the rate law for this step, at least? Rate equals Ka times B, right? Now, if I tell you that's the rate, what this rate is the rate of products forming, right? That rate is rate of products forming. So this is like, technically it's like rate of C, right? That's technically it. Does that make sense? So this is rate of C, Ka-B, right? So don't like, but you can just write it as rate, okay? A lot of people just write it as rate, okay? Now the next question I'm gonna give is, we have A plus B yields C, C yields D, or sorry, and then C, hopefully I remember how to do this, C plus D yields E, okay? Okay, and then the question will ask, like, derive an equation for the formation. Sorry, hold on, let me. Okay, hopefully that works. I just kind of made up that problem on the spot, so hopefully that works, but it should work. Formation of E. And sometimes he'll say like D concentration of E over dt, which all that means is the rate that the concentration of E is changing over time, or the rate of the reaction for E. Does that make sense? And then they'll say you can use stuff like K1 prime, and like K2. Okay. So we base it. Does that make sense? K1 prime, and K2. And I was saying, and you want it to consist of, A and B. Like, you want it to consist of like at least like all the concentrations, not just a lot. I mean, all right, sorry, let me just edit this. Sorry, go back to this, what I wrote initially, and then we'll just say concentration of, for the formation of products, right? Still the same thing. Okay, sorry about that. So you get in this, right? One relationship you guys should realize is this is step 1, this is step 2, right? And step 1 has a rate in the forward direction, which is little k1 I said, and then little k1 prime, or k negative 1, same thing, right? So technically there's a reverse component to it too, right? And then C to D, so the question basically asks, right? I think when it asks, like the way I took it was like I did old practice problems and I found this problem, and I kind of like, when it showed up on my quiz, I just translated it, right? But I think it wants to use like A and B forming, like the rate law for the second step using A and B. So the formation of the products, D and E, I guess, to specify, using, like, that incorporates A and B, K1 prime, and K2 all up. Does that make sense? You want like it to consist of everything. That's like the question, I guess. So like the exact question is like, derive the rate law for this mechanism, express constants in terms of the rate constants, K1 prime, and K2. So you need to include all those, and then show all work, okay? So basically, you know that this is K1 is forward direction, K1 prime is reverse direction, K2 is forward direction, and K2 prime is technically reverse direction, but it said not to include K2 prime. right? But I'm just writing it down so you guys can see, right? And each of these technically have like a big K1 and a big K2, right? So let's just start like doodling, right? I'll give you another relationship you should know. So big K1 I told you is equal to what? Little K1 over little K1 prime, right? What is big K1 also equal to? What over what? Products or reactants. Does that make sense? So what are the products of step 1? C over A and B. Okay, let's do the same for K2. Like this is not exactly like the order I do it in, but this is like I'm just helping you guys kind of see what's going on. K2 equals K2 over K2 prime equals D and E over C. Okay. So, what is the rates of formation of products of D and E equal to? Like for example, if this is my products I'm forming, remember how I said the rate law is like rate of products forming times K and something? So what would it be for this step? Rate equals K times concentration of C, right? The reactant to the first power, K, right? Does that make sense? Now, which K is it? Well, I'm going forward, so it'll be K2. That makes sense? If I told you what's the rate law in the reverse direction, it'll be rates equals, these are now my reactants going to my products, right? That, like in case he asks you that, but this is the one we care about, but in case he asks you like what's the rate of the reverse direction, it'll be rates equals K2 prime DE. Does that make sense? It's basically whatever you're initially starting with times the rate constant. So in this case, that's for step 2. For step 1, it's rates equals K1, A, and B. But what is this the rate of? This is the rate of C forming, right? We want the rate of D and E forming. Does that make sense? So we probably need to do something to this, right? Because basically what it's saying is I want you to say rates of D and E equals some expression, and that's what I want. That incorporates little k1 prime, and K2, right? And we know that for as of now, K2 times C equals the rate of formation of D and E. That make sense? Now, how do we incorporate all this? Well, we need to find some relationship that connects them to here, right? Usually this is through substitution. So, and we need to involve K1 and K1 prime, right? So we need to involve K1, K1 prime, and we have all this, but we need to input something here. Well, K2 is not involved in this expression, but C is. C is right here, right? So maybe if we like solve for C to one side, and we say C equals this, we can plug that in to here, and somehow maybe tie K1 and K1 prime. Does that make sense? It does. No, I'm serious. Say myself again, or are we good? Okay. So basically, what I'm saying is like if I say again, like the question never said like you have this, but I just wrote it there for you guys to, because he can give you this number instead of this. Okay. But in this case, K1 over K1 prime equals C over A times B. Okay. Well, let's multiply A and B onto this side, right? So we get C equals K1 over K1 prime times A times B. notice that's what C equals to. Because C is in this one, and C is in that one. Technically, we could solve for C on this side, but it wouldn't do us any good, because we need to instead we need to put it in terms of K1, K1 prime, K2. If we use this half, it would be K2 and K2 prime, which it didn't even say we can use. Does that make sense? So, basically, you're going to plug this over here, and then we get rate equals K1 times K2 over K1 prime times A times B. Does that make sense? And I think if I gave you like a third step, you should also be able to do that as well, right? It's about just like going back and then plugging it in, substituting, going back, substituting, stuff like that. Does that make sense? Any questions on this problem? Okay, so then you can also get like really basic problems. So let me give you guys a couple of these. Okay, so okay, I can give you like so you should have gotten something like this. And basically, you should have got something like rate of the reaction equals, so if I say what's the rate of the reaction, that's like the overall how fast the reaction is going, right? Now, there's the rate of the reaction overall, and then there's rate with respect to A, with respect to B. Rate of consumption of A, because A is a reactant, it's being depleted. Rate of production of C, how much that's being formed, right? So, the relationship is the change in concentration of A over the change in concentration of T, or not concentration, change of time. So it's like, basically, velocity is like meters, the change in meters over seconds, the change in concentration over time, the rate of the reaction, right? Now, the only thing you're gonna add here is, you're gonna just say 1 over A to account for the coefficient, because like, if I have 2, that's gonna be, if I have 2 of this, it's gonna not be consumed, it's gonna be consumed twice as fast, I think. Yeah, I think. And then I'm gonna put a negative sign, okay, to show that it's going down, right? And then same thing with B. B is also reactant, so it's negative 1 over B, d B dt. I could also just say rate of B instead of this. This is rate of A, and this is rate of C, or sorry, B, and then rate of C is 1 over C dC over dt. This is rate of C. Have you guys seen this before? So basically, this is like, and then this is, remember, this one's positive because it's a product, right? So he might ask you a question like, in the reaction, like in the generic reaction, 2A plus B yields 2C plus 2D plus E, right? What is the average rate of the reaction, right? And it's also given that the concentration of A went from tan polarity